Joe Rogan has finally revealed the shocking image that the Webb telescope captured, finally showing what Oumuamua looks like. In 2017, astronomers spotted something unusual passing through our solar system. It was Oumuamua, the first known interstellar object to visit us. But what do the images of Oumuamua reveal about its true nature, and could these pictures change everything we know about the universe? Let's dive into the details and find out what this interstellar visitor can tell us about the universe beyond our solar system. Back in 2017, the astronomy world got a massive surprise. The Pan-STARRS-1 telescope in Hawaii, which is always on the lookout for strange events happening around the universe, spotted something totally out of the ordinary. It was Oumuamua, the first ever observed interstellar object to pay our solar system a visit. The discovery of Oumuamua set off many questions among scientists and pretty much everyone who heard about it. People were fascinated for obvious reasons. Here was tangible proof that stuff from way beyond our solar system could come wandering in. And now, the James Webb Space Telescope has finally captured a shocking image of this object that has revealed its true nature. But Oumuamua wasn't intriguing just because of where it came from. This object had some pretty odd features that set it apart from the usual comets and asteroids scientists were used to seeing. For starters, its shape was something else. Most space rocks we encounter are somewhat roundish or irregular, but Oumuamua was long and skinny. It was a rock stretching out as long as a football field but with a fraction of the width. Then there's its path through space. Oumuamua zipped into our solar system at a speed and angle that made it clear it wasn't from around here. It was moving so fast that it was just passing through. It did not get caught up in orbiting the sun like most space debris that comes our way. And perhaps one of the most puzzling things about Oumuamua was its lack of a cometary tail. Most comets have iconic tails of gas and dust that stream out behind them. Oumuamua didn't have one of those, despite getting pretty close to the sun where you'd expect a comet to start spewing out material. Oumuamua stayed tailless. This was a big clue that it wasn't your typical comet or asteroid. Oumuamua's arrival was like nothing we'd ever seen before. Its interstellar origin, unusual shape, and unexpected behavior had everyone from professional astronomers to casual space fans asking questions. What was Oumuamua really? Where did it come from, and what could it tell us about the universe beyond our solar system? So how did the James Webb Space Telescope spot this strange object? The James Webb Space Telescope is a crucial piece of technology in space exploration. Named after James E. Webb, the pioneering NASA administrator who played a crucial role in the Apollo missions, the telescope represents the next leap forward in space observatories. Its journey from conception to the final frontier is a tale of collaboration, innovation, and the unyielding human spirit. The idea for the James Webb Space Telescope began taking shape in the late 1990s as a successor to the Hubble Space Telescope, with the ambition of looking deeper into the universe than ever before. Developed through an international collaboration led by NASA, with significant contributions from the European Space Agency and the Canadian Space Agency, the telescope was designed to answer fundamental questions about the universe's earliest stars and galaxies, the formation of solar systems, and the potential for life elsewhere. At the heart of the telescope's capabilities is its suite of advanced instruments and a massive 6.5-meter primary mirror composed of 18 hexagonal segments made from gold-coated beryllium. This mirror is significantly larger than Hubble's, allowing the telescope to collect more light and observe objects in far greater detail. The telescope's design enables it to observe in the infrared spectrum, which is essential for looking back in time to see the first galaxies that formed after the Big Bang, as their light has been stretched into infrared wavelengths by the expanding universe. The telescope is equipped with 4 main instruments: the near-infrared camera, the near-infrared spectrograph, the mid-infrared instrument, and the fine guidance sensor/near-infrared imager and slitless spectrograph. Each instrument plays a unique role, from capturing detailed images to analyzing the chemical composition of celestial objects. One of the James Webb Space Telescope's most groundbreaking features is its ability to observe the atmospheres of exoplanets, potentially identifying signs of habitability or even life. By analyzing the light from stars as it passes through an exoplanet's atmosphere, the telescope can detect chemical signatures that may indicate the presence of water vapor, carbon dioxide, methane, and other key molecules. The telescope's path to the stars was not without its challenges, including technical hurdles, budget overruns, and delays. However, after years of meticulous planning, construction, and testing, the telescope was finally launched on December 25, 2021 aboard an Ariane 5 rocket from French Guiana. The telescope then embarked on a month-long journey to its operational orbit at the second Lagrange point, about 1.5 million kilometers from Earth, where it remains shielded from the sun's heat and light, providing an unobstructed view of the universe. Since its deployment, it has begun to fulfill its promise, delivering breathtaking images and data that are reshaping our understanding of the universe. Its early achievements include capturing the most detailed views yet of distant galaxies, observing the atmospheres of exoplanets, and looking into dense cosmic dust clouds where new stars and planetary systems are being born. When Oumuamua came onto the scene, the James Webb Space Telescope became our best bet for getting a closer look. Its suite of instruments and unparalleled sensitivity to infrared light meant that it could capture details about Oumuamua's shape, size, and possibly even its composition that other telescopes couldn't. The build-up to the telescope's observation of Oumuamua was a major space event. Scientists and space enthusiasts alike were on the edge of their seats, waiting to see what the telescope would reveal. The anticipation was about the broader implications. This was our chance to gain insights that could apply to others like it, perhaps even shedding light on the building blocks of other solar systems. It was a test of our ability to observe and understand phenomena from other star systems using the most advanced tools at our disposal. The insights expected from this observation had the potential to open up new frontiers in our understanding of the universe, making it a pivotal moment in the field of astronomy. Why does this object cause so much fascination? Since Oumuamua zipped through our solar system, it's been the star of quite a few scientific head-scratchers. One of the biggest debates is its shape. Initially, some thought it looked like a cigar, long and skinny. But then a new camp started arguing that Oumuamua might actually be more pancake-like, flat and wide. This goes to the heart of understanding Oumuamua's journey through space and what forces it might have encountered along the way. Diving deeper, scientists have had all sorts of theories about what Oumuamua is made of and where it came from. One of the theories is the nitrogen ice hypothesis. According to this, Oumuamua is a chunk of nitrogen ice that broke off from a Pluto-like world in a distant star system. If true, this would explain its unusual acceleration as it passed by the Sun and tell us a bit about the neighborhood it came from. One of the most talked about theories is the idea that Oumuamua could be an artificial object, perhaps a probe sent by an advanced alien civilization. This speculation is fueled by its unusual acceleration as it passed through our solar system, which some scientists argue could be indicative of a light sail, a thin, wide surface propelled by solar radiation. While this theory leans more towards science fiction and lacks concrete evidence, it shows the huge impact Oumuamua has had on our imagination and our desire to find connections to other intelligent life in the universe. Another compelling hypothesis suggests that Oumuamua might be a fragment from a disrupted planet or a planetary building block known as a planetesimal from another star system. This theory says that Oumuamua could be a piece of a larger celestial body that was torn apart by gravitational forces, possibly during a close encounter with a star or a giant planet. Such an event could explain its elongated shape and unusual trajectory, as well as provide insights into the violent processes that can occur in young solar systems. While the true nature of Oumuamua may remain elusive, each theory contributes to a broader understanding of the processes at play in our universe. But with something as unusual as Oumuamua, it's easy to let our imaginations run wild. Sure, Oumuamua is weird, but jumping straight to extraterrestrial explanations without solid evidence isn't how science works. So as we piece together the puzzle that is Oumuamua, it's crucial to keep an open mind but also stay grounded. The truth about this interstellar visitor is likely to be strange enough without needing to venture into the world of science fiction. So, what did the recent image captured by the telescope reveal that has had the science world so excited? When the James Webb Space Telescope turned its gaze toward Oumuamua, the anticipation was palpable. It was the first time we were getting a real up-close look at an interstellar object that had wandered into our solar system. The image we got was groundbreaking. For the first time, we saw Oumuamua as a distinct object with features and characteristics. The level of detail was unlike anything we could have achieved with previous telescopes. This was our first real glimpse of something from another star system, and it was as thrilling as it sounds. This image, and the data that came with it, had the potential to either back up or destroy a lot of the theories that had been going around about Oumuamua. Was it the cigar-shaped rock some had imagined, or was it more pancake-like as others had speculated? The initial interpretations of the image started to give us some answers. Scientists began discussing the details, comparing them to the various models and predictions that had been made. For some theories, the image was a confirmation; for others, it was back to the drawing board. What was clear was that Oumuamua was continuing to surprise us. Its shape, which appeared more complex than many had anticipated, challenged our assumptions about what interstellar objects could look like. And as for its composition, the data suggested that Oumuamua might indeed be something quite unusual, not just a simple rock or ice ball. This revelation marked the beginning of a new era in our study of interstellar objects. With this level of detail and clarity, we could start to piece together more accurate stories of these wanderers. Oumuamua's visit and the data we've gathered from it could help us understand and provide insights into the processes at work in other star systems. The telescope's first image of Oumuamua was a key that started unlocking answers to some of our questions about the universe. And as we continue to study this image and gather more data, we're likely to find that Oumuamua has even more secrets to reveal. So, let's break down what this all means for our understanding of interstellar objects and their place in the grand scheme of things. First off, getting a clear shot of Oumuamua with the telescope is a big deal because it's our first real look at something from outside our solar system. This has given us a rare chance to study material from another part of the galaxy. This is key because every little detail we learn about Oumuamua can tell us something about where it came from and how it ended up here. But the implications go way beyond just one object. By studying Oumuamua, we're getting clues about the processes at work in other star systems. For example, if Oumuamua really is a chunk of nitrogen ice, as some theories suggest, it could mean that there are Pluto-like planets or objects in other star systems going through similar processes as in our own solar system. And here's another thing. Oumuamua's visit suggests that interstellar objects might be passing through our solar system more often than we thought. This has huge implications for how we think about our place in the universe. Each of these interstellar visitors has the potential to teach us something new about the universe. Thus, the telescope's observations of Oumuamua are helping us connect the dots between our own solar system and the wider universe. We're starting to see how the movement of interstellar objects like Oumuamua could be a common thread linking different star systems together. So as we continue to study Oumuamua and await the next space visitor, we're armed with better tools and a growing knowledge base. But what could the continued study of objects like Oumuamua reveal? For starters, we might uncover more about the building blocks of planet formation and the common or rare materials in other parts of the galaxy. We could learn about the forces and events that send these objects on their interstellar voyages, from gravitational nudges to massive collisions. The biggest question this object has created is about life beyond Earth. While interstellar objects like Oumuamua might not be harboring alien life, the materials they carry and the environments they've encountered could provide crucial context for understanding where and how life could exist in the universe. As we look to the future, the prospects for interstellar research are boundless. With each new discovery, we're expanding our understanding of the world and our place within it.